Let me share my screen. Everyone able to see my screen? Today we will learn, okay, thank you. Today we will learn memory management part 2. Earlier we have learned this topic, memory management. Today we will continue with this topic. We were in between, we were, sorry. In last class we learned about segmentation, then address generation, translation from logical address to physical address. We have learned all these things. So today we will continue with the memory management schemes, other things. Hardware support for relocation and limit register. What is relocation register and what is a limit register? Does anyone have any idea? The relocation register is used to protect user processes from each other and from changing operating system code and data. Relocation register contains values of smallest physical address, whereas limit register contains range of logical addresses. There's a mapping which needs to be done from logical to physical, and that mapping is done with the help of these registers. Relocation, what is relocation in memory management? Relocation is the process of assigning load address for position dependent code and data of a program and adjusting the code and data to reflect the assigned address. Some architectures avoid relocation entirely for deferring address assignment to runtime. That is known as zero address arithmetic. In addition, all addresses are checked to ensure they are within the range of the partition. An additional benefit of this scheme is that if a program is moved within memory, only its base register need to be amended. So this is quite quicker than having to modify every address reference within the program. If we look into the diagram, CPU, from CPU there is a logical address which is generated. Now one translation needs to be done from logical to physical address. The translation is done and limit register, the value of limit register is checked. Limit register logical address is less than the value of limit register. If it is less than, then there is a trap. What is a trap? Trap is nothing but an addressing error. So this is the hardware support for relocation. Now if the value of limit register is less than logical address, then then relocation, with the help of relocation address, physical memory is allocated and then kept into memory. So this is the support system for limit and relocation register. Is there, if there is any doubt, then you can ask, else I will move to next topic. Look carefully. If there is any doubt, then all of you can ask, else I will continue with another topic or with next slide.
Relocation register contains what kind of functions? Can you tell it
Relocation
one more time?
register, yes, relocation register is used to save the program from each other. It means it saves the program from writing or overwriting the contents of each other. So how does it save the program? It just relocates. That means memory space is not fixed. It keeps or it allocates the individual memory space for each process, and if there is a chance of overwriting it, then it swaps the process from one memory area to another memory area. That is the meaning of the term relocation. If we talk of memory address, we need to know that there are three types of memory address: symbolic address, relative address, and physical address. Symbolic addresses are addresses used in a source code. The variable names, constant, and instruction levels are the basic elements of the symbolic address space. If we talk about relative addresses, what is relative address? At the time of compilation, a compiler converts symbolic addresses into relative addresses. And what is physical address? The loader generates these addresses at the time when a program is loaded into main memory. That is the definition of physical addresses. So what is the job of relocation register? Relocation register translates from logical address to physical address. Virtual and physical address are same in compile time and load time address binding scheme. I think everyone knows the meaning of compile time binding, load time binding. Whenever you compile a program in C or any other language, then address binding comes under existence.
What's the meaning of addressing error?
Addressing error. If suppose it is suppose you have a box and the box contains no empty space, then what will happen? You will not be able to keep the thing, keep your material, keep your dress in that box. Then there will be an error. Yes, and there can be some more situations also. What are the other situations when there will be an error? When it is trying, when operating system is trying to keep the process in a space where where the space is less. Suppose it require 320 MB memory to keep that process, to allocate the memory successfully. However, 320 memory is not available. That means there is no contiguous allocation of 320 MB memory. 100 MB is available at one space. Then another 100 MB is available at another place. Then it will cause error because the process require contiguous allocation of space. Is it clear? One type.
Yes, ma'am.
Then there is also one type of error which is called error. Error is binding error. Binding error is again an error which is addressing error. This error that appears before some data binding wasn't correctly defined. Why is data binding needed? The binding is necessary to link the logical memory to physical memory. To know where the program is stored is necessary in order to access it. Load time binding, there's a concept of load time binding also. Load time binding when address is known at compile time but known at loading of the program, that is before running. That is about different types of binding and binding error. Now we come to multiple partition allocation. What is multiple partition allocation? Fixed size partitions are there. Each partition contains one process. So degree of programming limited by number of partitions. No, these fixed size partition, they have certain disadvantage. Fragmentation is one of the biggest disadvantage. It leads to wastage of memory space. So it is no longer used these days. Does anyone have any idea about the wastage, how wastage occurs? Let me draw a diagram. I'm sharing my whiteboard. I'm drawing a whiteboard. All of you look carefully. This is, suppose, a rectangular area and it is divided into blocks. Memory area is also divided into blocks. So there are blocks. Blocks are of different size. Some may be larger, some may be smaller. So these are different blocks. 1, 2, 3, 4 and 5 blocks are there. And suppose the data is kept and each of the block is having a certain size. Say this block is the biggest one and this is having 500 MB size. And similarly, each and every block is having its own size, 350 MB. Now, suppose other 3 blocks are full. If any process arrives and the process require 400 MB space for storage, then what will happen? Which it cannot be allocated to 350 MB because it requires greater storage. So it will be allocated to 500 MB. As a result, there will be a wastage of memory of 100 MB because that 100 MB will not be used by any other process. So it gets wasted.
Ma'am, can you repeat this? Your voice
Yes, I am repeating it.
got interrupted.
Yes, I am repeating it. Suppose memory, as all of you know, is divided into blocks. Different blocks are there. So, one of the block.
Ma'am, your voice is getting disturbed.
Hello. I'm shouting.
Yes, ma'am, your voice is getting disturbed again and again.
I am shouting at the top of my voice, but still, I think there is a network problem at maybe my side.
Yes, ma'am.
Yes. So, if there are, say, the memory area is divided into 5 blocks. One of the block whose size is 500 MB is the greatest block size. Other 3 blocks are filled up. That means they are occupied by other processes, so they are not free for allocation. Now there are only 2 blocks that are available, 500 MB and 300 MB. If a process which require 400 MB comes, then what will be done? Say I give the name of the blocks. This one is block A and this one is block B. So a process of 400 MB cannot be kept in block B because its size is 350 MB. So it will be kept in block A, which is of 500 MB. But 100 MB will get wasted because there will be a small fragment. Again, 350 MB is free. Now another process appears which I call process 2, which requires say 300 MB. Then it will be allocated to block B. After allocation, in block B, 50 MB space, 50 MB space is free. Now suppose another process P3 comes, which require, process P3 requires 150 MB. Process P requires 150 MB. Now what will happen? Can I allocate process P3 to any of the block? Block allocation can be done or no? Not getting any answers from you. All of you respond. Hello? Not getting.
Could you repeat the question again?
And others, they are not responding. Others try to respond, only 1 or 2 students are responding. What about others? Monisha Ghosh, you want to say something? You are listening or not?
Ma'am,
Yes.
ma'am, if any
Yes,
process
ma'am.
enters, ma'am, if any process enters within 100 or 50 MB, can I
Yes.
allocate to, because A is doing one process before only, and after that one more process enters of, for example, 80 MB. Can I give that same process to process, I mean, A block? Is it possible?
No. Just don't consider another situation. In this situation, tell me whether process P3 will be able to get 150 MB space, although 150 MB space is available. 100 MB space is available in block A and 50 MB space is available in process B.
The P3 processor will divide into 150.
No.
And
You cannot divide it. You cannot divide it. You need
So,
to.
ma'am, so, ma'am,
then
P3
it's
will
not
not be.
possible.
Yes.
So, ma'am,
Then
P3
it's not
blocking will not
possible.
possible.
Yes, Suraj, what you want to say?
Ma'am, then P3 will not be allocated to any. But ma'am, if that P3 process is of 80 MB, then can I allocate it to A1? I was asking that.
Couldn't understand. Tell me again. 50?
Ma'am, right now P3 process is of 150 MB, so we cannot allocate it to any of the blocks.
Yes.
But
So,
if the P3, ma'am, but my question is, if the P3 process is of 80 MB, if it is of 80 MB,
yes.
can
Then
I
allocation
allocate
is,
it to block A?
Yes, of course. Then
Okay.
you can allocate it. But try to understand the problem, all of you. 150 MB space is available. Some part is in A and some part is in B. But contiguously 150 MB is not available. So there is an error. What we need to done, there must be some techniques available which can be termed as relocation technique, where process A and B could be shifted a little in memory so that 150 MB contiguous memory allocation becomes available and processed P3 could be allocated to that memory area. Is it clear?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes. So this is the I was trying to explain why reallocation is required. What is the need of reallocation? Now let me go back to my slide. Variable size partitions. Operating systems keep a table indicating which part of memory are available and which are occupied. Available memory is represented as a set of holes of various sizes scattered throughout the memory. Throughout the memory area, the holes are scattered. When a process arrives and needs memory, the system searches the set for a hole that is large enough for this process. Okay. That means searching is done and the available hole or the available area is allocated which fits the need. When a process arrives and needs memory, the system searches the set for a hole that is large enough for the process. If the hole is too large, it is split into two parts. Suraj, I think this was the situation you were asking. If the hole is too large, it is split into two parts. One part is allocated to arriving process and the other part is returned to the set of hole. That means a large chunk of memory can be divided into two smaller parts. One bigger one and another smaller one. When a process arrives and needs memory, the system searches. Searching is done and then the allocation is done. When a process terminates, it releases its block of memory, which is then placed back in the set of hole. That means as soon as the energy area is released, it is again placed back or it is again kept in the original memory area. Okay. Dynamic storage allocation. How to satisfy a request of size n from a list of free holes. There are three memory management schemes: first fit, best fit, worst fit. Have any one of you heard about this memory management schemes earlier? First fit, worst fit and best fit? Any one of you?
No, ma'am.
So you have not heard.
No, ma'am.
First fit allocation is allocate the biggest hole that is big enough. That means whenever there is a space, you keep it there. You go on searching in memory area and say you are searching from the starting memory area, from the starting of the block. You have started your searching. As soon as you get a free hole, and if that hole is trying to fit or is fitting in that process, then that is allocated. Other things like wastage of memory, partition, these are not kept in consideration. So this is first fit. Searches starts from the beginning or at location where the previous first fit search ended. Best fit, allocate the smallest hole that is big enough, must search entire list unless ordered by size. Best fit produces the smallest leftover hole. Worst fit, allocate the largest hole, must also search entire list. Produces the largest leftover hole. First fit and best fit are better than worst fit in terms of decreasing time and storage utilization. But first fit is faster. Remember that why first fit is faster? First fit is faster because no searching is done. As no searching is done, as soon as a free memory space is obtained, the process is kept in that area. So definitely there is no searching process and it requires less time. But it is not the efficient one. Which one is the efficient one? Efficient one is that, yes, which is best fit. That means suppose 300 MB a process requires, let me again share my whiteboard. I think it will be clear. Because maybe some of you didn't understand. This is a memory block. It is divided into small partitions. Say this one, this is a block. It is 100 MB. Suppose this is a block. Similarly, different blocks are there. Of course, the blocks are continuous. I'm not continuous. There is no space between them. All of you, I think, able to view my screen, isn't it?
No, ma'am. The whiteboard is not visible.
Whiteboard is visible or not?
No, ma'am.
No, ma'am.
No,
Not
ma'am.
visible.
Not visible.
Not visible. Now whiteboard is visible. Whiteboard is visible or not?
Yes, ma'am. Now it's visible.
Okay, okay, okay. So
Ma'am.
there
Yes,
are,
ma'am.
okay, so there are
Yes,
different
ma'am.
blocks. I think all of you are able to see that I am trying to draw different blocks. These are the different blocks. Blocks can be of different shapes and size. So say these are different blocks of different size. And then 700, 700. This one is 900. Like that. These are memory area. What first fit will do? First fit will just look if there is 100 MB space is required. It will just come and it will just allocate the first available free space. Now suppose this one is 300, say for example. Now what will happen when the best fit occurs, when first fit occurs, this 100 is occupied earlier. What it will do, it will from 700 memory space, it will make a partition. It will make a partition and it will allocate 300 memory space to first block, and the another block will contain 400 memory space. So it will make a partition without searching that 300 MB of space is available, which can be easy, the process can be easily allocated to this 300 memory space. But instead of doing that, what is done? It partitions 700 MB into two parts. 700 MB, 700 MB, 700 is partitioned into 400 and 300, which leads to wastage of memory space, since partitions waste memory area. Some portion of the memory is occupied by the partitioning area, since partitioning information starting and end is kept, so it requires wastage of memory space. So we can conclude that best fit is the most appropriate memory allocation scheme. If there is any confusion, then I can repeat. Else, I will start with next one. This one shows fragmentation. Allocated memory may be slightly larger than requested memory. This difference in memory is called internal fragmentation. What is internal fragmentation? Unused memory that is internal to a partition. Compaction, a solution to external fragmentation. Shuffle memory contents to place all free memory together in one large block. Compaction is possible only if reallocation is dynamic and is done at execution time. It is expensive also. Compaction is expensive. Other solutions to external fragmentation. What are different possible solutions of external fragmentation? Permit the logical address space of the process to be non-contiguous, thus allowing a process to be allocated physical memory wherever such memory is available. Two methods, paging and segmentation, have been suggested. I have already cleared or already explained paging and segmentation. I hope all of you are going through that topic. If there is any confusion regarding paging and segmentation, try to modify it. Try to read it, and if you need some modifications in your information, modifications means you want to understand something more, then
Ma'am,
yes.
you didn't video yet. I mean lecture 16
Yes.
in YouTube.
Shankalita, one more thing. After the class, just call me once. Just when the class will end, call me once. I need to talk with you. Okay?
Okay, ma'am. Yes, ma'am.
Okay. Now, paging. Paging is a technique using which the non-contiguous memory may be allocated to a process. Avoids external fragmentation and compaction not required. Avoids problems of varying size memory chunk. Logical memory is partitioned into blocks of same size called pages. The packing store is divided into fixed size blocks that are of same size as the memory frames. When a process to be executed, its pages are loaded into any other available memory frames from the packing store. Page to frame mapping is kept track with a page table. The page number is used as an index to the page table. This is the formal definition of paging. So what is paging? It is using the how non-contiguous memory may be allocated to process. It can happen that if in earlier example which we have considered, there is 150 MB memory space. So 100 memory is allocated somewhere else and the rest 50 MB is allocated to somewhere else. That is the concept of paging. The basic purpose of operating system is to reduce load on the system and become more efficient. Consider that a process enters the system, that is swapped in. Every process we discussed is virtual. It might not be suitable and efficient to swap or load all the pages for the process at once. All the pages cannot be accessed at once. Why? Because as the program may only need a certain pages for the application to run. Understand this, that in an application, in a process, it is divided into several pages. If there are 10 pages of an application of a process, then at one time, maybe only 2 or 3 pages are required. So only those pages are kept in main memory. The other pages are not required, so they are not brought in the main memory. In fact, in cases a 1 GB application may be needed as little as 20 MB pages to be swapped, so there is no need to swap all at once. Demand paging is the process that solves this by only swapping pages on demand. This is known as lazy swapping. This demand paging is process. Remember that demand paging, the concept is important. It is the process that solves this by swapping pages on demand. Whenever there is a demand, whenever there is a need, then page is swapped out and swapped in. Demand paging in operating system. Swap in and swap out from main memory to secondary memory. This I have explained. All of you, please go through what I have taught, and if there is any confusion, clear your doubt. Okay? The meeting will end in a minute. I'm ending the meeting. If there is any question, get in touch with me.